sketch f of x. So we actually need to go backwards. Whereas before I told you we could not. Remember when we were looking at the graphs? Now we're actually going to go backwards. So I actually have this in a series of steps, and I'm really encouraging you to use the steps to do this. Each teacher will teach it totally different, but the outcome is the same. Okay, you are sketching a graph of f of x. It's not going to be perfect. Everyone's is not going to look identical. Like if you sketch a quadratic and I'm expecting your x-intercepts and your vertex to be in the same spot, yeah, because it's specific. Here we don't even know what f of x is. Okay, so we are speculating based on patterns. Everybody with me so far? Okay, so the first thing we're going to do, step number 1, is we are going to, this is our graph f prime. So we're getting our information from f prime. We're going to identify where f prime crosses the x-axis. Okay, so we have 2 spots, right? 1 and 3. You need to determine, bless you, if that value is a max, let's say a relative max, or relative min. Okay, so do you recall when f prime is above the x-axis, that means f prime is greater than 0. So that means that portion of the graph would be where f is increasing. We talked about this the other day. Anywhere where f prime is below the x-axis is where f prime is negative. Therefore, f of x is decreasing. Okay, this is a review of the other day. So what we're looking at here is we have a point at 1. And we want to know, like on a number line, just like this is a critical number. If I have 1 and 3, before 1, f prime is below the x-axis. So what is f doing? Is f increasing or decreasing? Decreasing. So that means it's like this, right? Yeah, 1 is right here. That's okay. Then from 1 to 3, meaning on this interval, f prime is above the x-axis. Therefore, f is increasing. Okay? And then after 3, which is right here on my number line, f is doing what? Decreasing. Okay, does everyone understand what we just did? That's this. Yes.
From last time, so in a f prime graph for concave up and down, if it's on the left,
it's the slope. Concave up and down has to do with the slope. We're not there yet. We're working on it. You said concave up and concave down. I'm only on increasing, decreasing. So there's different. Like the concavity of f prime has nothing to do with what you're doing.
No, I just wanted to review from last time. If it's we're looking at a f prime graph. If it's we want to say where it's concave up and down.
Where what is concave up and concave down? Where f is or where f prime is?
F prime is.
F prime's concavity has nothing. We're going back to f of x. So f prime's concavity has nothing to do with the graph of f of x. Okay?
Yeah.
Okay. If it comes back, let me know. So, what can you tell me about 1? We need to determine if x equals 1 is a relative minimum or a relative maximum. Relative minimum. So here, I'm just going to write relative min. So then what is x equals 3? Relative max. Okay, so listen. It does not matter where you put these points on the graph. It just depends on how spread out you want your graph. So, in this case, because I have 1 being a relative minimum, this is what I do. I usually put this point somewhere below the x-axis. So I have some flexibility to make my graph. Remember I made that one graph very exaggerated? The very first one I had the slope and then the concave up and the concave down. So I want it to be obvious what's happening. So because this is a relative minimum, you're picking anywhere. I could put it here, Kirsten could put it here, Ben could put it all the way down here. It is a choice. Okay. So then a relative max, where do you think I picked to put my point? Above. I want some space. I'm sketching a graph. Okay, so I'm just going to put it up here. So then what we just did was we marked our graph. So mark that value with a point. I'm writing the steps. Okay? And I just said if, and what you're looking at is if the graph is above or below. If the graph of f prime is above or below the x-axis. And that's what we are looking at to determine increasing and decreasing. Okay, so the second thing we're going to do is identify increasing or decreasing, and we just did that. So since we already have it on here, we're going to identify increase, decrease. Okay, and what we're going to do is we're going to connect our points with a straight line. And I'm going to call this the skeleton of our graph. Okay, because remember, we are sketching f of x. So I'm actually going to use a pencil to do this so that it'll be nice and light. So you guys told me before 1, f of x is decreasing. So if I were to sketch this decreasing, before, my graph is going to be going down like this to this point. Okay? From 1 to 3, f of x is increasing, so in order for me to connect these points, I need to draw a line that goes up like this. Agree? Okay, so then I go up like this. And then what happens after 3? Decreasing, so I'm just going to sketch a line like this. Now, this is not a curve, that's why it's called a skeleton, and I did it in pencil because it would be light. The third thing that we're going to do is, yes, look at f double prime, which is the slope of f prime. We will identify concavity, and we will mark the changes in concavity with a star on the skeleton. Okay, I'm going to move it up. Okay? This mark that we're making is our point of inflection, POI, point of inflection. Okay, so look at f prime's graph. It's an upside down parabola. How many times does this change slope? Once. Where? At x equals 2. So on x equals 2, wherever it is on your skeleton, I'm going to mark it with a star. Right there. So, okay. Before 2, my slope is positive. So what does that mean about my curve? Concave up, concave down. So does that make sense? Look at my skeleton. Doesn't that make sense? It's going to be concave up? Okay. And then what happens at 2? What does f of x do? Switches concavity to concave down. Sketch your curve. So you can see, this is one of your points. So I'm just going to sketch my curve. I'll use a different color. Okay, so like this. Concave up, like this. Is it going to be perfect? No. Concave down, include your point. This is f of x. Is it perfect? No. Is it good enough? Yes.